Hi, Math A. Welcome to online learning. So we used to do Desmos, but not everybody has a touchscreen. So we're going to go with PDF. So you should have digital. You can do it through Google App, or you can print it out, or you can do a lined piece of paper. Whatever you have access to would be great. So we're going to go through the lesson together, and then after the lesson, you'll try out the homework. I don't love the webcam, so I'm going to get off the webcam. All right. 6.2a lesson, comparing the perimeter and area of a polygon. So we want to know when we change the sides, what happens to the perimeter and what happens to the area. That's the point of the lesson. Below is an image of rectangle ABCD with dimensions 4 by 6. So I'm going to label that. Grab my pen. I got 4 by 6. On the first grid, provide a rectangle with sides twice as long. All right, well, if it was 4 by 6 and I'm making it twice as long, I have to go 4 times 2 is 8 and 6 times 2 is 12. So it's going to be 8 by 12. Label the new vertices E, F, G, H. And on the other grid, draw a rectangle with sides half as long. Well, half of 4 is 2 and half of 6 is 3. So my other rectangle is going to be 2 by 3. And label the new vertices I, J, K, L. So go ahead, pause the video, draw your two rectangles, and then we'll check back in. All right, I got my rectangles drawn. I labeled my corners. It matters where you put the letters. So where A was, you have to put E. Where A was on the top triangle, on the other one, you have to put I. You have to put the parts in corresponding places. Now we can go answer the questions below. Describe the method you used to double the length of each side. Well, I looked at the original dimensions and I multiplied by 2. Describe the method you used to make each side have half the length of the original side. Well, I took the original dimensions and I multiplied by a half. Do you think the area of the new rectangles change at the same rate as the sides? So, on the first rectangle, we made the sides twice as big. Is that area twice as big? On the second one, we made the rectangle half as small. Is the area half the size of the rectangle above? So think about that one. Pause the video, answer your 3 questions, and then we'll talk about it when you come back. All right, so on number 3, I said no. When I doubled the side lengths, the area was more than doubled. I can fit more than 2 of the original rectangles into this area of the new rectangle. So I know that it doesn't work out just the same way. All right, so here I am filling in the chart. It says, what's the dimensions? So our first one that we made on the left was 8 by 12. And the one we made on the right was 2 by 3. So then it asks us to get the perimeter. So for E, F, G, H, I have to go 8 plus 12 plus 8 plus 12 because I have to add up all the sides. So that would be 40. And for my bottom one, 2 plus 3 plus 2 plus 3, that's going to be 10. Okay, and then for area, I have to multiply the base and the height. So 8 times 12 is 96. And 2 times 3 is 6. So then it says change in lengths from the original rectangle. Well, we know the first one was double it. So we went 2 to 1. We made it twice as big. And on the second one, we made it half as small. Change in the perimeter from the original. Well, let's look. So when I'm looking here, the original perimeter was 20. Hey, and then 40, that's still twice as big. So that's still 2 to 1. But on the next one, when we look, half is small, and I go 20 to 10. I shouldn't have used that color. 20 to 10. I get times a half, so that's still 1 to 2. And then I have to look at the area and see, is it the same relationship or is it a different relationship? So 24 times 2 is not 96. 24 times 4 is 96. So the area became 4 times as big when I made the sides twice as big. Same kind of relationship on the bottom one. 4 times a fourth is 6. So this is 1, 2, 4. So if I make the sides twice as small, I'm making the area 4 times as small. So we have to think about that. So here, if my scale factor, that's comparing sides. If my scale factor is A to B, then my perimeter ratio is going to be the exact same. It's also going to be A to B. But my area ratio is not going to be the same. It's going to be A squared to B squared. Huh, why is that? So when I'm thinking of a length, a side, that's one-dimensional. A perimeter is also one-dimensional. It's just comparing a distance. But an area is not one-dimensional. It's number of square units that cover a shape. That is two-dimensional. And that's where we get that squaring from. All right, next page. Scroll on down. Below we have a rectangle that has 3 by 6. So I like to label it 3 by 6. On the first grid provided, draw a rectangle with sides 3 times as long. And on the other one, draw 1/3 times as long. So go ahead, pause the video, and do those, and then we'll get back. Okay, do your rectangles look the same? Are they labeled? All right, so now we're going to go down here and fill in the chart. Scrolling down too far. Okay, so we went from 3 by 6, and then we made 3 times as big, so 9 by 18. And then on the next one, we made it 3 times as small, so that went to 1 by 2. Perimeter, 9 plus 18 plus 9 plus 18, 54. Area, 9 times 18, 162. Okay, next one, perimeter, 1 plus 2 plus 1 plus 2, 6. Area, 1 times 2, 2. The change in length. On the first one, we made it 3 times as big. On the next one, we made it 3 times as small. I'm looking at that ratio, see if it's still holding true here. Yep. My perimeter is 3 times as big. So still 3 to 1. And on the next one, my perimeter is 1/3 as big. 1/3. Then we're looking at the area, and we realize that is not increasing by 3. 18 times 9 is 162. So this is 9 to 1. And 18 times 1/9 divided by 9 is 2. So 1 to 9. Again, we see that if you increase the sides by 3 times as much, you're increasing the area by 9 times as much. So if I increase the sides by 5 times as much, how much did I increase the area? So 5 squared, 25 times as big. All right, next problem. All right, we did it with 2 sets of rectangles. Now we're going to switch over to a triangle, and we're going to see, hey, does that relationship still work if I change the shape? So we want to make a triangle that is twice as big. And we want to make a triangle that is half as big, twice and half. Now, when I make the triangle, I have to keep the orientation the same. So I really have to pay attention to how the bottom is split by the height. So here I know that the base is 8, but I have to look at how the altitude, the height, is splitting the base. So when I have the height come down to the base, I'm seeing that it's cutting that 8 into a 2 and a 6. We have to pay attention to that. So when we make our shapes, we're cutting proportionally in the same manner. And here I have to pay attention to how big my height was. My height was 4. Okay. So when I make it twice as big, I want to do the same type of thing. On the bottom, I'm like, all right, 8 times 2 is 16. So I need to go 16 across, but I have to split my 16 into a 4 into a 12 because I doubled those lengths. So my drawing will begin. So I know when I go 4, there's going to be a height right there. And then when I go 12 more, okay. And then my height has to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I can connect, and it will be connected in the same type of manner. So we have D, F, and E. My whole base was twice as big, which is 16. But that 16 got split up into a 4 and a 12. And then my height is 8. We have to do the same type of thing when we're making it half as small. So half of 8 is 4. So I'm going 4 across. And I'm going 2 up. And I make a little tiny triangle. And this one is G, H, I. So you need to have it angled in the same type of manner. So you got to pay attention to that. All right, look at your triangles and then go ahead and try to answer questions 6, 7, 8, and then we'll check our answers. All right, so on number 6, when I wanted to double the triangle, I had to pay attention to how the height cuts the base. And I cut proportionally, but I doubled the lengths. Again, when I did it in half, I cut it proportionally, but I halved the lengths. And then I do think the angles or the new triangle are the same because it's sloped proportionally. It's still going over and up in the same type of manner. Here we go, next page. All right, what do you think will happen to the perimeter? What do you think will happen to the area? Well, I think it's going to be pretty much like the rectangle. I think the perimeter will be the same as how you increase the size. The perimeter will increase in the same manner as you increase the size. So if you double the sides, you'll double the perimeter. But I don't think that the area is going to work in the same type of manner. Because if I look like on the second one, when I cut the sides in half, that area is much smaller than half of that triangle. So here, the area will not increase in the same manner. When I doubled the area, doubled the sides, I made the area 4 times as big. Okay, what do you think will happen to the perimeter? I think the perimeter is going to increase in the same manner as we did the sides. What do you think will happen to the area? Well, when I look up there, when I doubled the sides, I made more than twice the area. So I'm going to go ahead and type my answers as you type yours, and then we'll double check it. Okay, so I said as you increase the sides, the perimeter will increase in the same factor. So if you double the sides, you double the area. Whoops, that should be perimeter. I need to cross that out. Let's cross that out and fix that one right there. This word should be perimeter. Okay, and the second one, as you increase the area, as the sides increase, the area does not increase the same factor. If you double the sides, you are making the area 4 times as big. Now we're going on to a new concept. Okay. We will now explore the relationship between triangles that have the same angle measures, but side lengths that are different. So these triangles are similar, and they're similar because their corresponding angles are congruent. The 15 matches the 15, the 117 matches the 117, the 48 matches the 48. So we know that angle P is congruent to angle A. And angle R is congruent to angle C. And angle Q is congruent to angle B. But the sides are not the same. The 18 corresponds to the 6, but the 18 is 3 times bigger than the 6. And the 6 corresponds to the 2, But again, the 6 is 3 times bigger than the 2. And the 21 corresponds to the 7, but the 21 is 3 times bigger than the 7. So if I looked and I put PR is going with AC and RQ is going with CB and BA, sorry, we got the other one, QP is going with BA. When I took those numbers, when I divided them, I always got 3, 2, 1 because my first triangle is 3 times bigger than my other triangle. So describe how they are similar and how they are different. So I'm going to type here. The corresponding angles are congruent. That's how they're the same. But the corresponding sides, they're not congruent. They're proportional. But the corresponding sides are proportional. The sides of one triangle were all 3 times bigger than the sides of the other triangle. Okay, what do you know about the lengths of the sides? I'm going to say exactly what I just did. The sides of one triangle are 3 times bigger than the other triangle. Remember, if I'm ever typing too fast for you, you got the ability to pause, rewind, fast forward, whatever you need to do to keep up. Next page. Okay, so we were talking about similar figures. Figures that have the same shape. So they're both rectangles, or they're both squares, or they're both circles, or both triangles. They're the same shape, but are not necessarily the same sides. And the sides are proportional and the angles are congruent. So what we did before, we had triangle PRQ. So triangle PRQ. And it was similar, our squiggly line means similar, to, we have to go in the same order. So P corresponded with A, and R corresponded with C, and Q corresponded with B. We have to write them in corresponding order. So that was going from, I'm going to draw it very small compared to what we had on the other page, but that was our 2 triangles that were corresponding, and one was 3 times smaller than the other. So PRQ was 3 times bigger than ACB. Okay, and then we had our corresponding parts, the ones that line up. We can tell from our statement what is lining up, and that's why it's important that you are writing it correctly. So angle P has to be congruent to angle A, and angle R has to be congruent to angle C, and angle Q has to be congruent to angle B. Again, I can also tell from the similarity statement the sides. AC is first, PQ is first on the other one, so PR is first on the other one, so PR over AC is equal to RQ over CB, which is equal to PQ over AB. So very, very important that you write your similarity statement in the same order. Otherwise, you're going to have a problem. All right, so now I want you to go down and I want you to try 13, 14, 15, 16, pause the video, and then come back and check your answers. All right, you should have got 4, 49, 49, and 6. If you got them all right, then you're ready to move on to the homework. If not, let's sit here and explain it for a minute. If they changed the dimension of the shape of a scale factor of 4, so that means it made it 4 times as big, scale factor, then the change in the perimeters. Well, we know that the scale factor is equal to the perimeter ratio. So if one's 4, the other one is 4. Number 14, if the change in the dimensions of the shape had a scale factor of 7, so we have a scale factor of 7 for the dimensions, the change in the shape's area. Scale factor is not equal to area. If scale factor is a to b, which is one-dimensional, the area ratio would have to be a squared to b squared. So we had to take the 7 and square it. That's where that 49 is coming from. Okay, if the change in the perimeter of the shape has a scale factor of 49, and that's the perimeter, then the change in the shape's dimensions, those are going to be exactly the same because, again, scale factor is equal to perimeter ratio. If the change in the area of the shapes was a scale factor of 36, so that's saying the area ratio is 36. We have to find the scale factor for the dimensions. So we're comparing area to dimension change. So I know the area is the squared of the scale factor. So I have to think 36. What times itself gets you 36? You get 6 squared is 36. So that means the scale factor is 6. All right. I'm saying bye for this lesson. Bye. So now you can try the homework, and then you can post a question in the Google Classroom, and one of your students in the class or I will come on and we'll get our questions all answered. Glad to see you doing well. Bye.